All right, quiz 3 solutions for Math 95. In the first part, we're given a rational equation. Yeah, that's what I wrote there. And asked to solve it, to find the solutions. So what you're going to do on a problem like this is your first step is you want to find the least common denominator. So really what I have is 2x over x plus 1 plus 1 over 1 equals 5 over x minus 1. You don't have to write out this step. You don't have to change the 1 into 1 over 1. But it might make it easier for you to see that I have three denominators, x plus 1, 1, and x minus 1. And the least common multiple of those three denominators would be x plus 1 times x minus 1. That is what I'm going to multiply all three of these terms by. So what I'm saying is instead of 2x over x plus 1, I'm going to get 2x times x plus 1 times x minus 1. 2x times my least common denominator over x plus 1. And then I'm going to get x plus 1 times x minus 1 times 1 divided by 1 x. What am I doing here? Divided by 1. Sorry, just multiplying the top by x plus 1 times x minus 1, which gets me here. And that's equal to 5 times that least common denominator. And over here, I have the x minus 1 on the bottom. Seems like I've made things a lot worse, but really I haven't because now I can cancel stuff out. Got an x plus 1 here and here. Nothing I can cancel out over here. X minus 1 here and here. What that leaves me with is 2x times x minus 1 plus x plus 1 times x minus 1 is equal to 5 times x plus 1. Not an easy equation to solve, but at least there's no fractions. The way we'll solve it is by combining like terms. Can't combine like terms until we get rid of all the parentheses, so I'll do that now. 2x times x minus 1 gives me 2x squared minus 2x. If I take that 2x and distribute it through. X plus 1 times x minus 1 is x squared minus 1. If you multiply these two polynomials together, FOIL it out if that's something you're familiar with. And then take this 5 and distribute it through and get 5x plus 5. Now I have this mess of an equation. Let's see, I got 2x squared and I got another x squared, so really I got 3 of these x squareds. For the x's, I got minus 2x here, and I'll do it one step at a time. Minus 2x minus 1 equals 5x plus 5. To solve these equations, I'm going to eventually have to factor, but it only helps factor when you have the equation set equal to 0. So I'll subtract 5x from both sides, and I'll subtract 5 from both sides. And that'll give me 3x squared minus 7x minus 6 equals 0. And so I want to factor this out. To factor this, let's see, I need two numbers. Factor this, it's a quadratic trinomial. Greatest common factor is just 1, so I can't make it any easier. It's got a leading coefficient that's not 1. That's unfortunate. That means it's a little bit harder. I need to find, one way you can do it is find two numbers that multiply to negative 18 and add to negative 7. Those two numbers are negative 9 and positive 2. And then replace 7x with negative 9x and positive 2x. The reason that was helpful is because now I have 4 terms, so I can factor by grouping. Pull out a 3x from the first group and you're left with x minus 3. Pull out a 2 from the next group and you're left with x minus 3. So if you pull out an x minus 3 from both of those, you got x minus 3 times 3x plus 2 equals 0. That tells you either x minus 3 equals 0 or 3x plus 2 equals 0. So either x equals 3 or 3x equals negative 2, in which case x equals negative 2/3. Whew, that was kind of an intense problem. There's my answer down there. I should note in passing that because I multiply both sides of the equation by x plus 1, had negative 1 been a solution, then I'd be multiplying both sides of the equation by 0. If you multiply both sides of the equation by 0, you lose information. So what I'm saying is because my least common denominator was x plus 1 times x minus 1, negative 1 can't be a solution, neither can positive 1. Fortunately, neither of those showed up as solutions, so I don't need to worry about it. All right, next one. After that difficult problem, I thought I should give you some that, I don't know if they're easy, but a little bit less work to do than we did up there. The basic idea here is you don't need to solve these. You don't need to find the answers. Just set them up. So the way we learn to set these up is kind of with this grid, distance, rate, time. We're rowing, meaning we're going upstream and downstream. And so I can set up, that's supposed to say stream. Set up this little grid here and fill in all the boxes. So distance, I'm going 3 miles upstream and 3 miles downstream, given to me in the problem. That's nice. Time, it takes me 2 hours total. That's rough. Doesn't tell me how much upstream and how much downstream. So if I call t the amount of time going upstream, then the rest of it, 2 minus t, is what I spend going downstream. Rate, I don't know the rate. If the current is 2 miles per hour, how fast do I row with no current? So I'm going to let the speed that I row with no current, let's let this be x. If my speed is normally x and I'm going into a 2 mile per hour current, my speed is 2 less than x. And if I have a 2 mile per hour current at my back, my speed is 2 more than x. Fill in the box like this. In order to set up a rational equation, I want to set up an equation that only has one variable. To get there to be only one variable, x, what I want to solve for, I have to get rid of the t's. To get rid of the t's, I'll notice that because distance equals rate times time, that time must be equal to distance divided by rate, if you divide both sides by r. So I can take this and say time, t, is equal to distance, 3, divided by rate, x minus 2. Or if I use the bottom one, time, 2 minus t, that doesn't look like 2 minus t, so I'll try again. 2 minus t is equal to distance, still 3, divided by the rate, x plus 2. I got these two equations. The problem is they have x's and t's in them. I don't want them to have x's and t's. I want just x's. But I know that t equals this thing. So I can take this equation right here, and instead of writing the letter t, I can write 2 minus what I found t to be equal to over here. I can substitute in this value for t. 2 minus t is equal to 3 over x plus 2. I'm going to say this is my answer, and then I'll write or equivalent because there's slightly different ways you can do this to get the same answer. Then do it again. Down here, it's a different river, and it's not me rowing anymore. It's my brother, apparently. Not that any of that matters. And I go upstream, or he, I guess, goes upstream and downstream, but still distance, rate, time. So I'm going to make the same grid. A little bit messier because I'm getting sick of doing these problems. All right, let's fill it out as best we can. It takes my brother 4 hours to row a total of 12 miles. There we go, 6 up and 6 down. So these are still 6. Oh, they're now 6. Time, it took him 4 hours. I don't know how much he spent going upstream, so I'll call it t. But I know that he spent the rest of it going downstream, so I can call that 4 minus t. And what about the rate? It's a little bit tricky. So in this problem, how fast is the current is what the question is. So I'm going to let the current be equal to x. So then he rows 3 normally, but he's going into a current. I don't know how fast the current is, so he starts out with the speed of 3, but then he goes x less than that. If the current is 2 miles per hour, he does 3 minus 2. If it's 1 mile per hour, it's 3 minus 1. Similarly, when the current is back, he goes 3 plus whatever the current is. So I can follow this exact same layout because time is equal to distance divided by rate. Time, t, is equal to distance 6 over rate 3 minus x using the top row. And time, 4 minus t, is equal to distance 6 divided by rate 3 plus x. And so I take this equation right here, except instead of writing t here, 4 minus t, I'll write what t is equal to. I'll say 4 minus 6 over 3 minus x is equal to 6 over 3 plus x. 3 plus x. And let this be my final answer. So what I did is I kind of took this equation, and I put that in for t right here to get over to here. I don't think those arrows helped at all. When I start just drawing arrows randomly, it's time to end the video, so I'll stop this here.